So today we're going to continue our review of some basic geometry things before we really jump into the trigonometry. So if you look at the picture given, it says, in the given image, we extend the sides of the angle NMP. So if I highlight that, NMP, remember that middle letter is where that vertex is, to form another angle, RMQ. So they extended N this way, they extended P this way to make Q, and then this angle in the middle. These two angles share the common vertex of M because the M is in the middle. These two angles are even more special because this angle and this angle are called vertical angles. So what's another pair of vertical angles in this picture? Hopefully you said something like angle QMN and angle, actually, hang on. That M is not in the right place. So on this page, they want me to find the measure of all these angles. On example 1, it says find the measure of angles 1, 2, 3, and 4 in the given image. So the first place I'm going to start is with 1 and 4. 1 and 4 are alternate exterior angles, so they should equal each other. So 3x plus 2 should equal 5x minus 40. I move the x's to one side and the not x's, the constants, to the other side. So I get 42 equals 2x, which means that x equals 21. But that is not the answer. This is where you have to read. It says it wants the measure of angle 1. So angle 1 is defined as 3 times x, which is 21, plus 2, which gets me an angle of 65. So this is 65 up here. That also means that angle 4 down here is 65 because they are alternate exterior angles and they are equivalent to each other. So there's angles 1 and 4. Angle 3 is a vertical angle with angle 1. So that also means angle 3, because it's a vertical angle, has the same measure. It's equal to 65. So now I'm left to just find angle 2 right here. Well, angle 1 plus angle 2 have to equal 180 degrees. They are supplementary. So if I do 65, which is angle 1, plus, let's just call this y for a second, plus y should equal 180. So y, which is what we called angle 2 is going to equal 115 degrees. And now you found all the angles they asked for. So now we have some special triangles to look at. So first of all, I hope that you remember that the sum of all the angles, the interior angles on a triangle, is 180 degrees. And so then we have these different kinds of triangles. Number 1 right here is an acute triangle. It means all the angles inside the triangle have acute values less than 90 but bigger than 0. A right angle or right triangle has exactly one right angle. An obtuse triangle has one obtuse angle inside of it. Equilateral, all the sides are the same. Isosceles, 2 sides are the same. And 3, scalene, means no sides are the same. So the next problem says it wants you to find the third measure in a triangle, given that 2 angles are 48 and 61. So it wants you to find the measure of angle x. So I know that a triangle adds up to 180, and that's going to equal 48 plus 61 plus angle x. So if I add this up and then subtract over, you should get that x equals 71 degrees. On the next page, we're going to look at similar triangles. Similar triangles are triangles that have exactly the same shape, but not necessarily the same size. So they're like scale factored, but they hold the same ratios between their sides or their angles. So we have A, B, and C, the blue, the red, and the green. Your notes aren't colored, sorry. that are all pairs of similar triangles. The two triangles in C not only have the same shape, but the exact same size. So C, they're exactly the same. They're not scaled factor at all. Triangles that are both the same shape and same size are known as congruent triangles. So letter C is congruent. They're similar, but they're so similar that they are congruent. A and B are just similar. If two triangles are congruent, then it is possible to pick one up and place it on top of the other so they coincide. They're exactly the same. If two triangles are congruent, then they must be similar. However, two triangles that are similar are not congruent, which is exactly what I wrote. Letter C is similar and thus congruent, but A and B are only similar. In the next set, or the next picture, it walks through what corresponds to what. So in these pictures, two lines here and two lines here mean that B and E correspond. One angle line here and one angle line here correspond. So A and D correspond. That means that this side, DE corresponds to AB. Angle C corresponds to angle F. So that means that EF corresponds to BC. And DF corresponds to AC. So corresponding angles are always going to have the same measure because the angles inside the triangle, even if we stretch it out or make it smaller and shrink it, the angles don't change inside the triangle. What changes is the side lengths. So corresponding angles have the same measure. Corresponding sides are proportional to one another. So we're going to use what we just read in that purple box on the previous page to answer these questions. It says, given that triangles ABC and NMP are similar, find all the unknown angle measures. So if this angle right here has one line and it's 45, then N and A correspond to one another, which means that P and C correspond, so this is 104 degrees. So then to find angle B, which is also angle M, you do 180 minus 104 minus 45, which will equal angle B, which also equals angle M, because corresponding angles have equal measure. So the measure of angle M is equal to 31 degrees. And then, fancy math writing, measure M corresponds to angle B. Fun math terms, therefore, this three little dots means therefore, angle B equals 31 degrees. Similarly, we use black. Angle C is congruent to angle P, and so therefore angle P is 104 degrees. Given the triangles ABC and triangle DFE are similar, find the length of the unknown sides in triangle DEF. So because they are triangles and they are similar, and we know they are similar because they say so right here, then we can do proportions. So I think in junior high you guys used a bat and ball. I learned it as a butterfly method, but AC right here corresponds to ED. So 16 is equivalent to this 8. Those are the similar sides. So if I want to find this side over here that I'm going to call X, EF corresponds to CB. So CB goes on top because I put the triangle I knew on top over X. So top and top came from this triangle right here. And then you can cross multiply bat and ball. Or you can say that this was multiplied by 2. 16 to get to 32 was multiplied by 2. Either way, but you're going to get that EF is going to equal 16. So I can write 16x equals 256. Then when you divide by 16, EF, which is what I called side X, is equal to 16. If I want to find DF, I'm going to go back and not use any values that I found. I'm going to use what I was given. So I'm going to do 16 over 8, ratios I knew, equals 24 over, we'll call this side y for a second, over y. So you can cross multiply. 8 times 24 is 192 equals 16y. And you should get that y equals 12. So this side df equals 12. 16 and 12. Last problem. Workers must measure the height of a building of a flagpole. They find at the instant when the shadow of the building is 18 meters long. The shadow of the flagpole is 27 meters long. The building is 10 feet high, or should say 10 meters high. Find the height of the flagpole. So everything's labeled and they're similar triangles. So I can say that 27 is similar to 18. So that means that 10, no, sorry, not 10. I'm going to call it x. X is similar to my 10. So you get 270 equals 18x. And then you're going to divide. You get the x equals 15 meters. Make sure you label those story answers with your units.